Alright, so this is video 4 for the Engine2 final. So in this one we're doing the terrain. I kind of went over a little bit of stuff earlier, but I'll do more in depth right now. So first is the terrain itself. So what it has in it is a little struct that is used for containing each AABB cell within the terrain, and it's just got a min and max corner. Talked about this down here in the data section, and the reason why I use that was because I don't want to hold like thousands of actual AABBs, because those have a lot more stuff inside of them. So I just held two vecs, a min and a max corner. But anyways, back up to this. For the actual terrain model, it just has a model, a graphics object, a texture, and a length of its side used in either pixels or cells. And then the data structure that I used for the array of these things was a double vector, like a multi-dimensional vector. The reason why I used that was because you don't know what the size of it could be. It could be a 100 by 100 or a million by a million height map or whatever. So I just went ahead and used that so it could scale properly. So here in the constructor where it actually creates the height map, this is pretty much just yanked from the graphics class from last quarter. But basically it reads each cell. It makes sure that it's a square. It stores an X, Y, and Z value, goes through each cell and assigns the height value. So this is creating the mesh in this section here. The X and Z values are set, and then the Y value. Yes, X and Z values are set, and Y value is dependent off of that the image at a certain location. And then so it creates the vertices. And then of course there's the winding section here, which basically winds the triangles within the terrain. And then these are the corners. Oh yeah, so this is still in the winding. And then from that it creates the actual model. And once it has the model, it then creates the graphics object and applies the texture and shader to it. So that's that for the constructor of the terrain model. Other than that, it just has a get model, a get side, and an update in case for whatever reason you wanted to change the position of it or whatever. Can do that. So then next was one of the managers. Yeah, I'll do the manager first. So the manager has the load terrain, a get terrain, and a get terrain model. I just realized those names are backwards. I will fix that right after this video. So yeah, so then the load terrain is pretty much very similar to the other managers that were used, throughout the early part of this engine. So I did the same thing where I created my own hash table. I assign a nickname, which is the key, and then the string for a file location. That's the value. And then basically what it does, so it has these terrain nodes, which are basically just things that are stored in a terrain table at a particular hash position. So these nodes have the key and the value in them. That's really all they're used for. So then there's the get terrain model, and then a get terrain object itself. And then of course the terrain manager is set up as a singleton with a, for my my hash table thing, a finite set of positions in the table. Let's see. Make sure I got. So yeah, there's no default terrain. So if the player wants to have a space game with no terrain, there's no terrain that loads in. They have to manually set it in the scene, the user scene. I briefly talked about the data for the actual model itself. It just has plain, couple other odds and ends, and a graphics object there. And then we went over that. The methods, it's got a lot of internal methods that are going on, especially, I talked about it earlier, but with the iterator, I won't do this all again, but it's got a subsection and it iterates through the subsection of the whole terrain. It does not iterate through the entire terrain. So that's really the important part there. So let's see. Projected a point onto, or words are hard. Projected a point onto a terrain. There we go. Getting an AABB from a vector position. I don't know why I have so much commented junk. This is when I was still like iterating through it. So this is constant time. It just finds it immediately. This part here. It just gets the position immediately. This is just checking to make sure you're on the terrain. So that's that. I don't have the getting a normal point under a terrain. I probably should have gotten that part, but I just was focusing on a lot of my other stuff, so I didn't get that part in. But I think we went over the terrain manager well enough. Collision with the terrain. So yes, I'll just show. I think I showed it already, but I'll do it again. The test with the terrain here is, I went over this. So it's got the tiered approach to it. If it's so there's the big AABB first over the terrain, and only those cells are checked. And then for the cells that pass that, the B sphere is checked. Then for the ones that pass that, it'll finally get down to the actual collision test with all of the AABBs that are within the B sphere against the actual object collision volume itself. So that's that. So that's cool. The only cells that are tested are the ones that are underneath the AABB, which is this section. Here we go. This one, the small box, the terrain. So that's that. Not copying a cell into a collection, that would be dumb. Because we're using the iterator here to do that efficiently. And then this is the last test for the tiered approach, so that's in there. This last part I can show later when I actually run the game, when I move off the sides of the terrain. So that's that, I believe. Why do I have so much commented code? So I think that's it for this video. Thanks.